my name is Alex, and I will be going through the reaction of this mechanism 15, of our this week's unit. Alrighty, so let's get started. So, get my pen. So on the left here we have our starting material. Essentially what is important is this alcohol group right here. And then on our right we have our tosylate, specifically the 4-toluene sulfonyl chloride, or TSCl for short. And what is important here is that this alcohol, it has 2 lone pairs, and this will be our acting nucleophile. And this sulfur right here will be our electrophile. And we can get started with the next slide and showing the arrow mechanism. So again, previously stated, this alcohol group will be our nucleophile, and this sulfur will be our electrophile. And on here on the right is shown our trigonal bipyramidal intermediate that it will form. So again, one of the lone pairs will come and react with this sulfur, pushing the electron flows with one of the double bonds in the oxygen, with the oxygen I meant, to go to the oxygen. And again, both of these oxygens have 2 lone pairs. Now, I'll proceed over towards the right, as we can see, with one of the oxygen gaining the additional electrons. We'll then have a total of 3 lone pairs, giving it an overall negative charge. While this previously alcohol group, well, it still has the OH, will have an overall positive charge, again forming this trigonal bipyramidal intermediate. So essentially this representation would be the sulfur, double bond oxygen, the other oxygen, chloride, and so on and so forth. Okay. So the reaction will proceed with one of the lone pairs returning back to sulfur and kicking out the halogen, and in this case would be the chloride. So this again would proceed towards the right, kicking out the chloride, with that having, I did not mean to do that, with that having a full set of valence electrons. My apologies. A full set of valence electrons and forming a double bond with the oxygen. Okay, and we still have this positive charge on this alcohol. So on the next step, we do have pyridine. So remember, in the beginning the reaction proceeded as TSCl with pyridine, and this here is pyridine. And what is special about this base is that it has it is hindered base. And this lone pair will actually go in and take that hydrogen, and the electrons from the hydrogen bonding to the oxygen will go to the oxygen here. Alrighty. So in the next step, we have here shown that the hydrogen is now taken up from the base, and that the electrons will flow back to the oxygen, giving it 2 lone pairs, with it having a neutral charge. And again, the inorganic product of the chloride is there as well. So this is our final product, which is also written as TSO. This here being TS, and the oxygen being right there. Hence TS for tosylate, and the O for the oxygen. So that is the reaction mechanism with the arrows drawn of this reaction. Thank you. Oh, and one additional thing that I would like to mention is that the stereochemistry of this reaction, since it does form that trigonal bipyramidal intermediate, and when it does perform this nucleophilic addition, there isn't specifically specific regiochemistry into this. As you can see how I have my, I guess you could say the substituents pointing upward, but in the overall reaction is more towards the left, the right, while mine is towards the left. You know, it can all rotate along this oxygen. Yeah, but what I believe naturally, it will space itself as far apart to lower the total amount of energy it has. So actually the way how they have it here, and you know, if the tosylate would go out here, it would be more, you know, it would have less energy, overall energy. I believe so. As you know, it's further apart, and the two rings, double bonded rings, would not be so close. So as long as everything is spaced out, I think that is what the preference for the regiochemistry and stereochemistry. Yep, that is all.